When we are using factoring and the principle of zero products to solve equations, there are several tricky situations that students aren't always prepared for right away. I would like you to have as painless a learning process as possible, so let me show you 5 circumstances, 5 examples of things that you may not otherwise be prepared for. First of all, on the left here, we have an example of something that's already been factored. X plus 6 times x plus 4. The problem is it's not factored equal to 0. And the principle of zero products doesn't work for other numbers. If you have a product equals 8, you cannot say for certain that one of the numbers is 8. It could be 2 times 4. It could be 1/2 times 16. There are a lot of products that end up equaling 8, and you really can't say anything for sure about either x plus 6 or x plus 4. So if that number there is not 0, you've got a major problem. And you cannot treat this problem like you would something that's equal to 0. Instead, what you have to do is multiply back out the x plus 6 times x plus 4. You get x squared plus 10x plus 24. And then force it to equal 0. Subtract the 8 and make it equal to 0. And then factor it again. And it won't factor into what it was factored before because you've changed it by moving the 8 over, but you factor it equal to 0, which is the important part. Once you have it factored equal to 0, then we can do just like we were doing in the introductory video for 5.7, break it up as either this part equals 0 or that part equals 0, which gives you either x equals -8 or x equals -2. So if it's not equal to 0, you've got to get it equal to 0 before you do anything else. Don't just bulldoze your way forward as if it's any other problem. That's a major problem and needs to get fixed immediately. So that's one thing to be aware of. Products have to be equal to 0. Second issue, one over here on the right. It's already equal to 0, so that's not the problem this time. The problem this time is the factoring is a little more difficult, and unfortunately, some factoring is easy and some factoring is not. And here in 5.7, where we're learning to use factoring to solve equations, the same will be true. Some factoring will be easy and some factoring will be hard. Here, you might want to pause your video for a second and try factoring this yourself, and then press play and I'll show you how it factors. All right. This one factors into 3x minus 1 times 4x plus 3. Once you have it factored, just like any other principle of zero product situation, we have either 3x minus 1 equals 0 or 4x plus 3 equals 0. And you'll notice these two equations are not as simple as the ones we typically have. These aren't just immediately done in one step. 3x minus 1 equals 0. If you move the 1 over to the other side, you're not done. You also have to divide by 3. And yes, indeed, that means sometimes your answers will come out to be fractions. Fractions are fairly common as answers to these problems. A similar thing happens with the second half of the equation. If you move the 3 to the other side, you still have to divide by the 4 to get the x by itself. And that also produces a fraction. So the answers we have here are 1/3 or -3/4. So the factoring can be a little more challenging. The answers can be a little messier. It's not always going to be simple things like 2 or -8. Sometimes the answers are messier and more challenging. Next couple of examples. These ones have to do with factoring challenges. The one on the left, that has 1, 2, 3, 4 terms. Remember when we were going over our factoring strategy guide, that if you have 4 terms, the only thing that you might be able to do is factoring by grouping. So we're going to have to use factoring by grouping here. Group the first 2, group the second 2, and see what you can pull out of each group. Again, you might want to pause the video, try doing it yourself, and then press play, see if you get the same thing I'm about to get. All right, so from the first group, it looks like we have a common factor of x squared, and that leaves 2x plus 3. From the second group, it looks like we have a common factor of -4, and that also leaves 2x plus 3, which means we have an overall common factor of 2x plus 3. And when we factor out the 2x plus 3, we're left with x squared minus 4. That's not all the factoring you can do. You can also factor the x squared minus 4. That's a difference of squares. So when you factor that, you're going to factor into x plus 2 times x minus 2. Notice this isn't a product of two numbers equal to 0. This is a product of three factors equals 0. But the principle of zero products works just fine here. If you have three numbers multiplied together, one of them has to be 0. You can't have three non-zero numbers multiply out to 0. One of them's going to equal 0. So either 2x plus 3 equals 0, or x plus 2 equals 0, or x minus 2 equals 0. So for this first one, you have to move the 3 to the other side, and then you have to divide by the 2. So you get -3 over 2 for that one. But the other two are a lot simpler. You get -2 and +2. And then this one on the right. This one on the right isn't difficult, but students often have sort of a blind spot about it. They have trouble seeing what they're supposed to do. They get too fixated on the fancier types of factoring, and they try to use FOIL, or they maybe think of it as a difference of squares, and that doesn't work, and they stumble to factor it when really it's actually the easiest type of factoring. Don't forget that if you go back to our strategy for factoring, one of the very first steps is look for a common factor. And 8x squared minus 16x, there's a common factor of 8x. And when you factor that out, that leaves x minus 2. The other thing that's a little tricky here is the product of two factors here. One of the factors doesn't have parentheses. So if it helps, and this isn't required, this is something that you may or may not do, maybe you'll just think about it in your mind. You might put parentheses around that 8x, just like you have parentheses around the x minus 2, just to remind you, there are two products here. So you can have 8x equals 0, or x minus 2 equals 0, just like in any other product. This first one, when you divide by 8, you get a very simple answer, which there's nothing wrong with getting an answer of 0. That's an answer. 0 is a number. And this one over here, you move the 2 over and you get 2. All right, one more example, and this one isn't particularly difficult, but it is a situation that might catch you by surprise if you aren't fully prepared for it. And it's problems like this. Well, it's already equal to 0. That's not the problem. The factoring doesn't look particularly difficult here. So when we go to factor this, let's see, you might want to pause the video, take a second, and then press play. All right, so it turns out it factors into x minus 4 times x minus 4. And I'm going to proceed forward as if I didn't just notice something. If you think you've noticed something that is a different way of looking at this problem, you're probably right, but I'm going to pretend I didn't see it. And I'm going to treat it just like the other ones. I'm going to break it up as either this part equals 0 or this part equals 0. And then I'll say, okay, that means the answer is either x equals 4, or, on the other hand, maybe x equals 4 instead. And that's obviously silly. Why would you say that x equals 4 twice? Why would you repeat yourself? So this part here is a complete waste. Don't say the same thing twice. Don't repeat yourself. If x equals 4 is a possible answer, then x equals 4 is a possible answer. You don't have to say it multiple times. What that means is, even though a problem might factor, it's still possible that there's only one answer. There's not always two answers. Sometimes there's just one.